I can cover half of what I'm going to possibly ask you in Lab Exam 1, or I can do a minimal covering and let you guys do the rest of it yourself. How many want to just do work on this yourself for Lab Exam 1? How many want me to cover half of Lab Exam 1 material right now? Amen. Are we ready? This is going to be the same thing, people. Everything that comes out of my mouth today and next week is going to be seen on Lab Exam 1. Did you guys just experience that, looking at the answers? Everything that was in those pictures came out of my mouth first 2 weeks in lab. Everything for all 60 stations for Lab Exam 1 is going to come out of my mouth if you want to hear it. Starting on page 7, you see we have microscopic bone structures and long bone structures. I'm going to actually flip them and do long bone structures first, and when I do that, you'll see why. Then we're going to jump over here to page 15 and do skeletal terms. Then I'm going to cover 8 out of 10 extra credit points, that's what it's saying there, on articulations for Lab Exam 1 is going to be on page 13 and 14. And then I'm going to cover everything that is listed on pages 7, 8, and 9 for the appendicular skeleton. Are we ready? Are we ready? All right, let's skip down to the long bone structures first. So in your PowerPoint, we got to skip through these guys here and go to this. Every long bone, all of these are long bones. All of these are long bones. But there are even some bones that aren't even long, like these metacarpals and phalanges, are all technically long bone. And a long bone, technically, even if it's not long, has a centerpiece that's hollow, called the diaphysis. That's the center of it, that's hollow. And 2 knobby ends. Each knobby end is called an epiphysis. Look at the spelling. Now look at the spelling on page 7. Is that a typo? You got to look at page 7.
Yes.
It's not a typo. Epiphyses with an E between the S's is plural. One S is singular, and each long bone has 2. That's why it's spelled in the laboratory objectives, epiphyses. Everybody got it? Okay, let's do some critical thinking. How many knobby ends can I pin with one pin? Lab exams are about models and bones with pins in it. You were rotating around the room. How many can I pin with one pin? One. Would you ever use the E on Lab Exam 1? No. Make sure you got this spelling. Lab Exam 1. I between the S's. Epiphysis. Okay? In the epiphysis, you will see this bony ridge landmark. This is a remnant of the old growth plate. It is perpendicular to the long axis of the long bones. If it's going this way, the epiphyseal line in the epiphysis is going to go this way. There's a bony ridge through the epiphyses we call the epiphyseal line. In lecture, after lecture exam 1, I'm going to cover how this is relevant. Epiphyseal line. In this picture, it's pretty subtle. But if you look at it carefully, you can see this bony ridge going through it. It's not straight. This one's kind of an S turn. Okay. In the diaphysis, it's hollow like a pipe. The hollow space that's in the middle of the diaphysis is called the medullary cavity. And you should get used to these words. We covered it with the hair today in lecture. Cortex, or cortical, is the outer structure. The medullary cavity in the diaphysis is in the center of the diaphysis, so they call it medullary cavity. Everybody got it? We saw that in the hair today, didn't we? The inside of the hair is medulla, outside is cortex. And that's true of the adrenal glands. That's true of lymph nodes. That's true of your spleen. Okay? And it's true of bone. Compact bone, which you see in the slide, is always on the outside. So in clinics, you might hear some doctor call it cortical bone, because it's always outer. Cortical bone is compact bone. Spongy bone is medullary bone, it's always inner. All right, so here's the epiphysis, and you can see that this is chock full of these little bony struts, and those bony struts are called trabeculae. What does the E at the end mean?
More than one.
Plural. How many can you, I pin with one pin.
One.
Should never use the E. How come I don't see your hands moving? You should never use the E on lab exam. Never use the E on a lab exam. But all these trabeculae make it look spongy, hence it's called spongy bone. You actually have three synonyms you can use. Spongy bone, cancellous bone, since it's always inside, medullary bone. Compact bone is always outer. You can call it compact bone or cortical bone. Okay. Now if you look at the diaphysis, it is almost all compact bone. There's just a little bit of trabeculae lining the medullary cavity. That little bit of trabeculae is spongy bone. But it's like 98% compact bone, 2% spongy bone. Everybody see that? On the next slide, you can actually see it transitioning from 98 compact, 2% spongy, and it flip-flops. It becomes this eggshell thin compact bone, 2%, and 98% is spongy bone. It's like the ratio flips. Everybody see that? But spongy bone is always inner, compact bone is always outer. Nutrient canals are so large, you can see it with the naked eye. Can you see where I put this pointer in this nutrient canal? Can you see it? You can see it across the room, can't you? Big old canals with huge blood vessels coming up out of it. The reason why you have a bunch of nutrient canals on the epiphyses is in the epiphyses, between these trabeculae is red bone marrow. That's where all your blood cells come from, and they're coming flying out in these large blood vessels going out these holes. And you can see it with the naked eye. That's what I would write next to nutrient canal. Large enough to see with the naked eye. In fact, you can probably see it from across the room. Everybody got it? Now go up above. You guys have got to get used to lab being directed by this your best friend. If you're looking at the PowerPoint and you don't have your laboratory objectives, you're not taking advantage of your best friend. Go up above to microscopic structures and see where it says perforating canals. Full name is Volkmann's. Everybody see that? You can't see those with the naked eye. They're microscopic. Perforating canals you cannot see with the naked eye. They're microscopic. Nutrient canals are huge. You can see it from across the room. And there it is right there. Okay? Any questions? Everybody see how the diaphysis is hollow like a pipe? Everybody see that? Now we can go to microscopic bone structures. Any questions on long bone structures? Here's this model right here. I got two of them. There's one here, There's one up in that cabinet on the top left. For lab exam 1, that's stations 1 and 2. Okay, points are going right past your ears. Stations 1 and 2 for lab exam 1, each has one of these. Stations 3 and 4 are longbow structures. Everybody see how I'm covering part of this cut diaphysis with my finger? Everybody see that? This is like one slice of the overall pipe. One slice of the pie. Are you imagining this? That's this model. This is taken from a diaphysis. And the way I'm holding it now is the piece of this pie that my finger's covering. Now does this model make sense? In other words, up here at the top is the outside of the bone. What I'm holding it with my left hand is actually from the medullary cavity. Everybody see how it's a slice of a diaphysis? Can you see the cut tree trunks? That's compact bone. In the diaphysis, it's 98% compact bone with a bunch of osteons, cut tree trunk, and only 2% with trabeculae, the spongy bone. In the diaphysis, the vast majority of this is compact bone, osteons. But this is it right here. So this white layer is outside the bone. That white is periosteum. This incomplete white is lining the medullary cavity. That white is endosteum, and it's an incomplete layer. Endosteum is incomplete. Periosteum is complete. Everybody see that? Does this help organize what this model is?
Yeah.
It's one slice of the pie of a diaphysis. Periosteum on the outside, medullary cavity would be here. In fact, that's what I would write. Over here, medullary cavity on that side. Okay, the cut tree trunks are the osteons, and on this model they telescoped out 2 of them. They just telescoped it out. So each ring is now stepping on 2 of these. Everybody got it? They actually do 2 apiece on this side, 1 apiece on this side. But the rest of them are just cut flat, so it looks like the cut tree trunk. Are you following what those 2 are that are, they're just telescoped up? Each ring is called a lamella. What does the E mean? Plural. How many lamellae can I pin with 1 pin? Cross off the E. Each lamella is one tree ring in what looks like a cut tree trunk. Everybody got it? There they are, osteon, with each tree ring. Notice in the cracks between rings is where we find the lacunae wedged in. They're not in the middle of a tree ring, they're in the cracks between tree rings. Can you see that? How many lacuna can I pin with 1 pin? Cross off the E. Living in that space is an osteocyte. Everybody got it? The name of the space is lacuna. The name of the cell that lives in the space is osteocyte. This is just like dermal papillae and papillary layer of the dermis. Exactly like it. I will pin one of these guys, and on one question I'll ask what is the name of the space. And the name of the space is called lacuna. Same pin, different question. What is the name of the cell that lives where the 2-way pin is located? Osteocyte. The name of the cell is osteocyte, the name of the space is lacuna, answer my question. Notice that the blood supply for all these cells is in the center of the cut tree trunk of the osteon. That's the central canal. You can call it haversian if you want, but I would call it central canal. It could be big C, little c. Still get the point. And it also will remind you because it's in the center of the osteon. That's a descriptive name, central canal. Everybody got it? Osteons run parallel the long axis of a long bone. Osteons run parallel the long axis of a long bone. So out here in the outer rings are lacunae, and living cells live there. How do they get oxygen and nutrients? When the blood supply is in the middle, by these radiating channels called canaliculi. That's how this guy can get oxygen and nutrients and get rid of waste and CO2. Canaliculi perforate lamellae. Any questions? All right. Now, if osteons run parallel to the long bone, that means this long bone in this model runs vertically, like this. Everybody got it? Everybody got it?
Yes.
Well, if the osteons are running vertically, that means the red lines that you see are vertical are running up central canals. Any of these red lines that are vertical is in a central canal. Every red line here that you see that's vertical is in a central canal. Any red line here that you see here that's not vertical is in a perforating canal. Do I need to repeat that? Every red line that you see here that's straight vertical is in a central canal. Here. Every red line here that you see on this screen that's not vertical is in a perforating canal. And you can't see them with a naked eye. They are microscopic.
Either of those? Both of those?
Yeah, it would be very difficult to cut into bone and actually see osteons and central canals. They are also microscopic. Any questions? That's why they call this Volkmann's canal. This is a perforating canal because it's not vertical. Everybody understand that? The periosteum is attached to the surface of the bone by these perforating fibers. These are the horizontal white lines. Perforating fibers. You can call them Sharpies if you want. You're just asking for misspelling. Okay, then this is from the medullary cavity, because this is the side with the endosteum, the 2% spongy bone, that view. Basically on this view, if it's white, it's endosteum. If it's not white, it's trabeculae. From this view, if it's white, it's endosteum. If it's not white, it's trabeculae. That's the 2% spongy bone. Vast majority of this, though, is osteons. And that's what I would do, actually. Is on page 7, I would draw a little line from trabeculae up to the line above it to spongy bone. Trabeculae is characteristic of spongy bone. And then on the top left of page 7, I would draw a line from osteon down to compact bone. Osteons are characteristic of compact bone. Trabeculae are characteristics of spongy bone. You never find osteons in spongy bone. You never find trabeculae in compact bone. Everybody get it? Any questions? For the first two sections. All right, we're gonna go ahead and take a break in a second. If you're gonna stick around, this is what I would do if I was you. Right there where it says clavicle, pectoral girdle, and upper limb, and then clavicle, our first bone, is everybody on page 7? I would number that, sternal end number 1, acromial end number 2, conoid tubercle 3, glenoid cavity or fossa number 4. Just go right down the line. You should finish at 27. And I'm telling you why. When I'm gonna go over the whole thing, this will go a lot faster if you write out numbers instead of writing it out. Are we clear? Just write out the numbers on your PowerPoints. Don't spell it out, it's gonna take us too long, especially with 34 people. Then, on page 8, start with scaphoid 28. I would number it all the way down, but I would not number ilium, ischium, or pubis. Don't number those, just number anterior inferior iliac spine, which should be 39. Anterior superior iliac spine number 40, iliac crest 41, go down, but you do have to give obturator foramen and acetabulum numbers. If you do that correctly, the bottom of the page should end at 66. The 3 bones of the os coxa, ilium, ischium, pubis. Don't, because there's smaller structures on the same line, so don't write numbers for ilium, ischium, pubis.
Where do we start, you say again?
Okay, I'm gonna say it again. You're starting on the sternal end of the clavicles, number 1. If you do it right, the bottom of the page should be 27, correct? That means scaphoid on the top of page 8 is 28. You're gonna go all the way down and number them, but you're not gonna number phalanges. You got pollex and fingers. You're gonna go all the way down. 39 is anterior inferior iliac spine. Just keep going down. Make sure you give numbers to obturator foramen and acetabulum, which should be 49 and 50. If you do it correctly, you should be down at the bottom of the page at number 66. Correct? Correct? And then you can continue number it through the phalanges on page 9, that's where we end. All right, so go ahead and get some caffeine. Trying to get something to help you stay awake. Hey, everybody listen to me, because Tuesday Lab didn't believe me, and several students got left out. Believe me, at 2 o'clock on that clock on the wall, I start whether you're here or not. Okay? Ask Tuesday Lab. I will start at 2 o'clock. Whether you're here or not.
What number did you end at?